being recorded. And yeah, meeting minutes from our last 2 meetings actually ready to be approved. I sent the link out. There's just 2 pull requests. Does anybody have any comments or any concerns on that, or is anybody willing to say give that the okay to go ahead and publish this?
That's fine.
Okay. All right, so we'll go ahead and push those out. And didn't have anything else on the agenda. I think we've got a great topic that Callie's going to introduce for us on how to potentially pull security bits for ROS from PKCS URI or potentially a data URI. I think there's lots of possibilities in there, but I think there might be some practical hurdles to overcome. But with that, I'm going to hand it over to Callie to just introduce your use case, and then we can start walking through where to get from here.
Yeah, thanks, Sid. Can you hear me all right?
Yeah, you're good.
Awesome. So let me share my screen. Yeah, I also included or forwarded this invitation to 2 of our developers, Manuel and Tianci, who are also on the call. So that's why we have some new faces at least. So are you able to see my screen?
Yep, I can see it.
Yes, sir.
Excellent. So basically, first I would like to tell a little bit what we are doing to give a little bit background and who we are. So I represent TII, which is the Technology Innovation Institute located in UAE. And okay, there we go. The organization basically consists of multiple research centers, basically all more or less related to information security and cryptography. We have like quantum research, cryptography, and so on. And what we are part of is this last one here, Secure Systems Research Center. And what we do is basically we deal with topics such as the hardware hardening, software hardening, system integrity, communication hardening, and cloud integration, and then secure resilient platforms, which is very core of this project that we are doing with drones. So the very project we are doing is autonomous drone fleet, and basically this is quite a big project. We have a lot of university collaboration as well around the world, including Europe, US, and UAE. This is meant to be a platform for further development and for different use cases, enabling research and maybe some business cases as well. But we are not productizing this as this project. So we are working on a platform and doing a lot of research on different related topics on this. Here are some use cases that potentially this drone platform could be used. The idea is that we have a ground control, which is based in the cloud. There we can run some heavy computational things such as data analysis and machine learning and sort of things. Then we have the middle layer, which is what we call fog drones. These are relatively heavy-duty drones with some computing power. They communicate with each other in a mesh network, but also 4G, 5G, LTE connectivity to the cloud. And then they work more or less like as a motherships for what we call edge drones, which are much more limited small drones, and so on. So this is the high level concept. The idea is that the drone system can do missions autonomously. So we define a mission in the cloud, push it forward to the swarm, and they start to divide the tasks and do what they are supposed to do. And So what this means in the ROS2 context is that we have this computer on board. We are now focusing on these FOC drones, which are these sort of like a motherships in between. So they are these heavy-duty drones with some computing powers. Everything there runs in ROS network, so components inside the drone as well as between different drones communicate over ROS nodes. What else? So basically, the idea is that we have these virtual environments on this computer. They are logically divided according to different trust zones or actual operational features. It's like a moving target, but the idea is that we are having a hypervisor and then virtual machines on top of this. And so the basic beef of the whole thing are different ROS nodes collecting data, controlling sensors, controlling the flight commands, all this mission execution. All this is like a big ROS2 network. What we have had in mind, and we will come to this very topic soon, what I have also raised in the chat in Matrix earlier, is that we are basically looking to have this enclave on board of each drone, and this works as on-board HSA more or less. It's a crypto backend where we store keys safely. So it's in a ROS context that would mean that we are storing the private keys there. Like for sure we have some other use cases for it as well, but in this use case, or ROS context, the idea is that all the SROS private keys for all these different environments or components are in this one hardened, isolated crypto backend. And then similarly, we are looking to have all the CAs in the cloud. So we have the root of trust or the root CA in the cloud, and also the intermediate CAs there. And during the provisioning of the system, we will be signing these artifacts, like public artifacts like ACLs, as well as the identity certificates for each of these environments in the cloud and moving them here. As we are not productizing it, I think at this point we can assume that doing this moving the certificates and moving the certificate request by hand is totally fine. Yeah, so basically I went a little bit ahead of myself. This is basically explaining what I just went through. So currently, as we have been playing with SROS, we basically have been a little bit struggling now to find the ways to protect these private keys. So we would like to suggest some kind of PKCS 11 based approach or some standard crypto API. It seems that DDS security extension includes PKCS 11 in the specification, but yeah, it's implementation that probably needs to be worked on. I think that this is something that is not only us who would be potentially looking after. So I think this could benefit many enterprise level or actual other projects who need to really harden the key management, and similarly to the CA. This is basically just a picture that I already showed in the Matrix chat. So external CA, I think this is not rocket science. This is like how any web server, for example, would be provisioned. So you have the CA and the intermediates in the cloud. Then the drones themselves would generate their own private keys or the key pair, and also generate then the CSR or the certificate signing request that will be sent to the cloud to be signed. and then cloud will provide back to the drone the signed certificate for the drone and a copy of its own CAs, and then the signed permissions file. So very, very basic thing. I think this is much news for any of us on the call who have ever set up a TLS, for example. Then similarly to this PKCS 11 use case, we would have this public components here on the local file system as they are today. If you are running this ROS2 security generate commands, it will create this local enclave and local keys. So basically, what we are looking for is that only the secrets would be stored in the crypto backend, and these public components can still reside in the local file system, and this would mean the certificates and then these signed artifacts. So basically, whether it's PKCS 11 or some other crypto backend, it would basically need to be able to take key creation requests and key consuming requests, such as sign and encrypt and decrypt. This is very basic PKCS 11 use case. The benefit of this, I think, would be that if it's PKCS 11, is that then this crypto backend is fully replaceable. So you can use HSMs, you can use whatever PKCS 11 supported backends you want, whether on premise, on board, on cloud, whatnot. So this is industry standard and should enable a lot of use cases. And this is pretty much it. So I wanted to keep it short so that we have some time to discussion as well. This is also very high level, so I want to emphasize that we are very open for different approaches, and if there are some good ideas to forward, we are all ears. So yeah, that's about it. Are there any questions about us or the use case?
Hi, it's Iker here. I'm working with the FastDDS team. Mm-hmm. I think everything's quite clear in your presentation. As you already know, FastDDS at this moment does not support PKCS, but I do see the benefits of the layout that you presented. I don't know how much or how hard it will be to make all this into FastDDS, but I'm really willing to at least have some contact with you and maybe dig deeper into all the details and all the problems that you are facing, so that maybe we can start working towards that. So just for you to know that we are open to start working on this.
Okay, this sounds really good, and we are also collaborating on different open source projects where we can. Obviously, we also have limited resources, but I think that we should definitely meet up and talk in detail and see if we could also maybe help with something there.
Mm-hmm.
And yeah, about the technologies, yeah, we are definitely using the fast RTPS, and yeah, we are running the Foxy version of ROS2 right now. So should be the latest as far as I know.
Yeah.
Does anyone have any other questions or thoughts about the design itself? Because this seems like this was what was the intent of the original design of ROS2. Anyone with any history can speak to that. Does this fit well with the original design plans?
For the certificate, certificate signing requests. Is that something you foresee would be online over ROS networks, or would that be something out of band?
I think this would be out of band, like a side channel thingy. This would be like a provisioning phase of this whole ROS network, so it doesn't need to happen in the ROS network. What I have personally on mind is that maybe the SROS toolset could support this, like generating the CSR, showing them on the screen, copying it over to the external CA, and then receive the certificate. So I think that implementing this is probably quite trivial, given that everything is already happening there. It's just like the flow is a little bit different, probably.
Yeah, I think everything here is relatively achievable. It's just the technical thing is, does anyone know about the state of PKCS 11 in Python's cryptography library? Well, one thing we kind of had to work on is helping with their SMIME signing support to that. And,
yeah. So basically, where these two different points come together is that when you initialize this enclave on the drone or on the robot, and you generate the key, this key must be generated over PKCS 11 in the crypto backend, and then and this is basically the flow where you're also generating the certificate request and all this. But when it comes to the actual, once you have the certificate, it's in the file system. So basically, we are not looking for any, how to say, certificate generations or even CSR generation or anything like that over PKCS 11, just consuming the private key. And again, I think this is very analogical for how web servers work when they have TLS enabled and they are using HSM.
what would the crypto backend that's interfacing with the TPM modules kind of look like? That's like an extension to RMW to kind of provide the DDS vendors where to look, or is that something the DDS vendors already provide?
No, actually the crypto backend is something that we will be creating ourselves. It's like another research project we have going on, and it's not only for the drones. It's something that we are doing otherwise. So it's basically like our own HSM implementation, very lightweight and versatile. But basically, the beauty of this whole thing is that it should not matter too much what the crypto backend is and how it looks like if it's able to communicate over PKCS 11. So you can basically hook anything behind that, then like put soft HSM or you could basically use smart cards or whatever you want as a backend there.
So you guys are gonna have like a modified extension for the DDS security plugins that can take and a reference or a pointer to PKS 11 certificate storage, like some kind of URI of like either
exactly. So
file system or device to load, and then that's handled.
Exactly. So looking at how things have been done in the industry before, there are different ways to kind of implement this. So very often you have this PKCS 11 library from the crypto backend vendor, and you need to somehow point this key to it. So if looking at the web servers, for example, you can use something called PKCS 11 URI. It's somewhat standardized way. And so basically when you have your configuration file for ROS2 or SROS, you would give PKCS 11 URI instead of the file name for this private key. Yeah, and I think that would be the most elegant way. Then some vendors use something called wrapper key files. So basically you still have a key in the file system, but it's just basically a pointer to the actual key in the enclave. So this is more like a legacy solution for things like Apache that doesn't, or mod SSL in Apache that doesn't really understand anything else than files. So that's why some HSM vendors, do this sort of approach. But I think PKCS 11 URI would be the most elegant and modern way.
Well, in fact, the security DS standard does define the PKCS URIs as one of the options in order to set the permissions on the rest of the files. So apart from the file protocol, we could use PKCS. I mean, it's right there, it's in the standard, it's just that we are not supporting it right now.
Right, okay.
So wouldn't that require update to the middleware? Because right now the middleware assumes that everything is on a file somewhere. So we'd have to change that to allow accepting a URI. Is that correct?
Yeah, at this moment, when we are configuring the middleware, all the properties referring to the security configuration, they are set, or at least we are only supporting file URIs. So it would be just change that into so that we could support the PKCS. Obviously, we will have to I don't know, link to some library supporting that, and then we will have to change whatever configuration we are writing on the properties to use a different URI.
So is that going to require a change to the ROS2 design doc? Just to specify how we're going to locate that, similar to what we did last time when we reworked how the enclaves were set up. Is this going to mean that we just have to find a way to support? I mean, that it sounds like that's going to be one of the early things, is to figure out, nail down what the design is for how we put in a PKCS URI.
Yeah, I think so.
Okay, let me ask another question for you. As you were going through this, it looks pretty clear that you still have a file system on all the drones.
Yeah.
And so you still have the ability to drop a permissions of governance XML file in a directory for the drone. Is that correct?
That's correct, yeah.
Okay, so there's no, at this point, there's no need to support the data URI, which allows you to work without a file system. That's a completely separate problem, right?
Yeah, that's another thing. Yeah, you are referring to this other topic in the discourse, right? And
Right.
Yeah. I think this doesn't concern us too much. So we have file systems in all these environments. So
Okay.
Yeah.
All right. Yeah, because that's when I was looking at that beforehand, I did this. I mean, it makes perfect sense, right? Permissions and governance, the permissions and governance XML signed files still have to reside on disk, so they're still going to be, accessed by file URI. So that still needs that enclave. kind of configuration set up. So
yeah, so those two, those two files, they are basically here on this environment next to these CA files. I think they are more or less public components. By public, I mean that they don't need to be specifically encrypted nor put to the enclave, so we can consume them directly from the file system.
okay. So we have a lot
by
of folks,
enclave, I mean the crypto backend. Sorry, not the enclave. Yeah, sorry.
Yeah, so
Confused.
we have a lot of folks online. I want to just pause for a minute to see if anybody else has any questions or wants to dig into it any further, or if you've got a similar use case. I mean, we don't want to solve for just one problem. I think we want to solve for all of them. But if you've got similar use case or thoughts on this before we kind of figure out where to go from here. Does anybody have any more comments to add?
Hey, I'm Tomoya with Sony. Thanks for the talk. Can you share the slides on somewhere that we can access?
Yes, I can probably send them
if possible.
to Sid. Yeah, I think Sid, you can probably put them somewhere with the meeting minutes, right?
Yeah, absolutely. If you want to share them with me, I'll make them. I'll add them to the meeting minutes, and then I'll if we have them somewhere, I'll drop a note in the Matrix chat as well.
Okay,
yeah,
sounds perfect. I got one more question. That's kind of like off topic, but what is the isolated environment? I think I missed it. Did you mention about hypervisor?
Yeah, so in this context, it means at least with the current design, it means a virtual machine, like a hardened virtual machine.
I see. Okay.
We have like basically a computer PC on board, and then we are running hypervisor with multiple virtual machines there.
Okay, thank you.
So the yellow boxes here are virtual machines.
Yeah.
Anyone else have anything to add or questions? Thoughts about how this might apply to anything you're working on?
The hierarchical intermittent certificate authorities, I think, are a good approach in like handling the permissions at scale. So like if you have like a large deployment of robots, obviously you don't want to have to start revoking every identity certificate for every node that might be a part of a robot. If a particular robot is compromised, it seems a lot more simple just to revoke one certificate, intermittent certificate authority that's associated with that device. So I like that. Do you see other more advanced means of identification or maybe other decentralized means of authority than these networks? I'm thinking maybe something more exotic, like either using DLT, distributed ledgers, or something else for doing the identity management.
Yeah, that's a good question. Like we have a lot of hooks in the ocean, so to say, and we are investigating a lot of different options. But yeah, right now, this is the way we are currently focusing. But we have like different layers as well. Like I mentioned, we are working in a mesh network, for example, and there is a whole another basically authentication schemes and identity management layer there. So yeah, for this SROS context, this has been what we have had in mind, but obviously we are very open for hearing other thoughts as well, and if you have some good ideas.
Okay.
I had a question for Iker on DDS support. Do you currently support the intermediate certificates and certificate revocation, so that if a drone were compromised, you could actually revoke that certificate, and the rest of the drones in the fleet would know about that?
I know we do not support revocation for permissions. I'm not really sure about certificates, but I would say we don't. But I would have to check that.
Yeah, I think Ellie, that was part of your design, was to be able to kick someone out of the fleet, if you will.
And that makes sense.
Yeah, that's definitely one of the use case. So if we have a compromised unit, for example, we can kick it out. So it's basically revocation here. But I think it was also part of your plan, Sid, in the documentation, right?
Yeah, and that was part of, I know Marco was working on a scenario that he was looking for that as well. You mentioned you've dug into a lot of things. Have you looked at all at just key management and key management protocols? I know that seems like that's one of the modern ways to push keys out to edge devices, something like that. Is there? I honestly haven't looked at that in the context of ROS. Did you notice any fits there? Does that work at all in this?
Well, another interface that could potentially be used here is KMIP. But I basically, when it comes to the key management itself, I don't think we have a lot of hierarchies here, or the structure is not very complicated. So, and we are not pushing keys back and forth. Like every identity creates their own keys and store them in their own local enclaves. So we don't have like centralized key management, so to say, planned. So that's why I consider our key management seem very simple. But again, definitely if somebody has good ideas in that regard, all ears. And about KMIP, it would be a substitute for PKCS 11 here. It's more like a key management interface, although they have some overlaps with PKCS 11 as well. But I don't think KMIP is part of the DDS specification either. So that's why I got a little bit fond and fan of PKCS 11 for this case.
Right. Yeah, I just ran across it in the documentation, and I haven't seen it in the DDS. It's not in the DDS specs. So.
Yeah. Unfortunately, I have another call actually that I need to jump to. But if there are some more questions, I can still stretch for a few minutes.
Okay, yeah, we appreciate your time. I think we'll follow up on Matrix and outline some next steps. I have a feeling the next thing is probably for you and Aker and maybe a few others to just roundtable on where to go from here. I have a feeling there's probably a little bit of design and then a lot of implementation is my guess.
Yeah, I was going to propose that.
Okay.
Yeah.
So let's follow up on chat because we are running a little bit over, and we'll do that. So that was a great discussion. I'll just follow on. Does anybody else have anything else for the meeting or anything to add from here? Okay, so not hearing anything, I'll go ahead and close the meeting, and I'll say, yeah, let's again follow up. Aker and Callie, I'll leave it to you to kind of drive this for now. And if you want to have a meeting before our next scheduled meeting in a month, just let us know. Reach out on Matrix.
Yeah, sure. That sounds really good.
Okay, we'll keep in touch through Matrix. Good.
Okay. All right. Well, thank you very much. It's been a great discussion, and I'll write up the notes and post them out for you.
Perfect.
Right.
And I'll be sending the slides.
Great. Thank you.
Thank you.
All right. Thanks, everybody. Appreciate it.
Thank you.
Thank you very
you.
much.
Bye-bye.